Hi everyone, continuing on the engine monitor build today, but I've decided to put all the connectors on the top just because that gives me the most area to lay them out. I can lay them out, without running into space issues. So I'll bring in for a quick closer look and we'll put some holes in it. So I've got some of these sensor connector things which I'm going to use for the 3 pressure sensors and for the glow plug and the injector outputs. Just looking at the box, the new igniter module, ignition exciter module, whatever you call it, I think I'm just going to put in the corner here and put a metal screen in the way there to try and screen it off from everything else because it'll be noisy, and then we'll poke that connector out the front, or that face of the box, so we can connect to it on the other side, which is why I didn't put this connector here. So on my Dero there is a slightly hidden function. Along the bottom you've got a circle mode where you can put holes on a pitch circle diameter PCD sort of thing, and you can put lines at an angle, holes at an angle, and you can do random other things like cutting radii and triangles, or whatever angle. But under this one there's a thing called grid hole, which I only just discovered today actually, and that allows you to do a grid of holes. Clues in the name I suppose. So I've set it up. These holes are 18mm apart, so that one in the middle is going to be at 9. So I've done it as 9 by 9, which will give me more holes than I need, but I can just skip to the appropriate ones. That's part of the reason for the sanity check marks on the masking tape there. Just so that I'm starting in the right place and I can just move appropriately from there. So I've done 11 by 7, and that's to cover the 2 rows. So there'd be 1, 2, 3, 4, 5, 6, 7 for the second one underneath, so sort of a gap of 19 between the two. 18, sorry. Oh, 12, 13, 14, 15. I need 15. So I'm going to change number X to 15 into angle 0 because they're just in a rectilinear arrangement. And I think we need to exit. We need to find our 0 point and go back in and run the grid. So I've just screwed a bit of plywood to the mill bed, clamped it to the mill bed. I've put a single screw in the corner of this plate, and I'm just going to use a 1, 2, 4 block to roughly square this up. Doesn't have to be super accurate because it's just cosmetic how square this is, but that'll do. Close enough. We're only drilling, so I'm not going to clamp it down any better than that. Now I could do this in the mill, but because I'm lazy and impatient, I'm doing it like this. It's very thin aluminium, so it's not really going to be a problem. And they're nice sharp taps, so that's all of those screwed on. I've only put 1 screw in. I think I'm only going to need 1 screw, to be honest. I've got 2 just in case I feel like I need them, but at least for the moment I've still got to drill more holes to put the actual wires through, but I'll come to that later. So I now need to do the hole for that, which is just a plain hole, and then I will design something for the thermocouple interfaces. So that's going to go there. Then we've got this. So the two little thermocouple modules sitting there like that. This sits on top. Clamps them in there, so we can put the wires for the thermocouples in and do the screws up, but everything else is protected. And then I've got holes in the bottom there for the wires to drop through. So that's that top plate basically finished now. I had to open up some of the holes just to get the wires out nicely, but there we are. I still need to attach some wires to that one, but I'll do that a bit later. Now I want to do the bottom. For the power in, I was going to use these 4mm banana posts. They'll just go in the side there, a couple of holes, nice and easy. The igniter, we're going to put the hole in for that. And then we've got the Raspberry Pi, which is going to be over here. I think it's a bit much to try and align it, make loads of holes for all the ports and stuff. So what I'm going to do is just have it inboard so there's room to plug stuff in, and then we'll just have a big plastic cable grommet to allow us to route stuff in if we need to. But I mean, essentially it should just be a case of turning the power on and letting this thing run. You know, connecting through just an Ethernet cable. But if I do need to do anything on this, it's, you know, gives me options. I want to divide off this section here, which has got the high voltage module in it because of noise. So what I'm going to use is this piece of aluminium. Still got its protective covering on, which is helpful because it's nice for marking out. This box is cast, so it does have draft on it, and it looks like the draft's about 1 degree, so that gives us about 1 millimeter of width change, so it's narrower at the bottom there and gets wider at the top. So I've basically just roughly marked on there. I'm going to try and cut along that line with the bench shear. I'm not sure I can trim that off just because it basically tapers to nothing, so I'm just going to file that until it fits. Alright, that fits. Next to do this lot. 3D printed this interface plate to mount all the bits and bobs on, so that will go in there. Centre marked some holes, going to drill them out. well, that all continued for quite a while, taking things out, putting things back in, so on. But this is what we've ended up with. It's all wired in now. So we've got the main Pi, which does the sort of dashboard from which you control it. We've got the Pi Pico, which is a little microcontroller. I'm using that simply because it's got an analog to digital converter on for the pressure sensors. Just cheaper than an ADC module for the Pi. That talks to the Pi over UART. We've then got the two switch modules. One's for the injectors, one's for the glow plugs. Got a couple of fuses here for those switches because they're switching reasonably high currents. This is the little tacho board that I've made. It's just a little 555 circuit, turning a inductive spike from the tacho sensor into a nice square pulse for the Pico to count. I've got a little boost module there which takes the 12 volts in and boosts it up to about 20 volts because the pressure sensors require at the very least sort of about 13 volts, but I thought I'd give them plenty of headroom. So that's that. We've got a nice long Ethernet cable for connecting to the remote laptop. The USB cable is purely for if any programming needs to be done to that Pico. Yes, I could probably have done it via the Pi, but it's just easier to have it dangling out. This isn't a finished product. This is just a lash up to make something work. And we've got a little circuit there. It's got a filter on to try and keep the noise from getting to the rest of the electronics for the high voltage module. That's the adapter that we made last time, connected to the big long cable. And then this is a box for the glow plugs. Because the glow plugs need so much power, I needed to put a switch box much more local to the engine. So what we're going to do is have a car battery basically sitting right next to it, which will go in here, it gets switched in here, and then it's going to go out to the glow plugs, rather than running a 3-meter cable basically from the control box to the engine. This is going to sit at the end of the cable, and then this will switch the glow plugs on and off, and in fact control the power to the glow plugs so that they don't cook. And then these are all the pressure sensors with their cables. Sensor there, there's one there, and that's the tacho. So this is the dashboard. We've got the two temperatures, the three fuel pressures, RPM, and the pulse width modulation percentage that we're setting for each of the injector and the glow plug. The glow plug is fixed at 50%, just simply because I don't want to burn the glow plugs out. The injector will go up to 100%, although I don't think that should be necessary. We've got a big E-stop button that basically turns off everything that is controlled by this, so the injector, the glow plug, and the igniter. It will just kill all three in one click. We've got a save data button here that basically just logs all the values that are coming in to Node-RED to a file, just so that there's a record of everything on the laptop. Oh, and over here is the maximum values that have been recorded, just for reference. Right, well that's that basically finished. It took a lot longer than I thought, and has rather detracted from the main content of this channel, but this is basically what's been taking all my time for the past few weeks. So I'm going to send this off, and hopefully in a few weeks time, maybe a month, we'll actually get to run the thing. Hope you enjoyed that, and there should be some more machining related content very soon. Like to say thank you to all the new subscribers. The channel has grown pretty much, well, for about 10% in the past couple of months, which is quite phenomenal really. now getting very close to 1,500 subscribers. That's quite a milestone. I've only reached 1,000 at Christmas, so getting another 500 in less than a year is quite amazing. So thank you to all of you. Thank you to everyone else who's still sticking with me. I hope to see you next time. Thanks for watching.